So picking up right where we left off, we're at example 2 now. So we're going to draw another histogram based off of this frequency distribution. So we have some weights of discarded material, and we have our frequencies. So again, the first thing we need is our class boundaries. So we got 5 classes, so 1 extra puts us at 6. 6. Okay, so again, our second class boundary to start, so between 0.9 and 1.0. So if we average those, we should get 0.95. And hopefully you remember this example from before. So our first class boundary, if we realize our class width is 1, class width is 1, so if we subtract 1, we do get a negative result here. So negative 0.05. So, and the reason why is because our first class starts at 0, our boundary has to be a little bit before that, so it's going to have to be negative. But now we can add 1, add 1, add 1, and add 1 more. So that gets our class boundaries, so now we should be good to go. So now sometimes I like to just turn my book and just kind of write them this way. Oops. And make sure you start with the first one. So negative 0.05, 0.95, 1.95, and so on. Okay, so there's our boundaries. And so these are going to be weights. And if you want to put pounds next to it. And then we got our frequencies now. So again, what's our highest one? 26. Now we definitely don't have 26 boxes here, so we're going to have to scale it. So how should we scale it? Let's see how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 boxes, and we got to go up to 26. So how big are we going to want for each box? Well, probably by 3s, huh? We can't go by 2s, that won't be enough. So we'll have to go by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And so this will be our frequencies. All right, so we should be good now to draw our bars. Now, because we're not going to have ones that are multiples of 3, we're going to have to just kind of guesstimate exactly where they go. So first one is a frequency of 5. So, if you want to try to say, okay, well, I'll, kind of partition that into 3 parts, and then I'll go, try to get it as accurate as possible. I'm not going to be too crazy with this stuff, but you do want to try to get it fairly accurate. 26. So 26 is going to be closer to 27 than it is to 24. Then the next one's 15. Oh, that's a nice one. And 12 is a nice one. Last one's 4, so we got to go just a little bit above. And that gets our frequency distribution for that one. Not too shabby, right? All right, let's do a couple more just to make sure we got it down. Now, for this next one, it says use the following frequency distribution to construct its relative frequency histogram. So here's the twist. So let's first find our relative frequencies, and then we'll worry about our class boundaries. So how do we find relative frequencies again? Well, we're going to have to add these up. So it looks like we got, what, 25? All right, so 1 out of 25 is going to be what, 4%? 0.04. Now remember, you know, I like to skip steps, so I won't. So remember, divide it on your calculator first, get the decimal, and then change it to a percent. So 4%. Now that one's pretty easy. 0%. And my lead keeps coming out. So 15 out of 25 looks like 0.6. So 60%. 7 out of 25 is 0.28. 28%. 2 out of 25 is 0.08. So 8%. All right, so we can get our relative frequencies pretty quick. Now we got to get our boundaries. 5 classes, 6 boundaries. 1, 2, 3, 4, 5, 6. All right, and looking diagonally. So it looks like 13.5 for our second one. And then our class width equals, not 3, it's going to be 4. So we got to subtract 4 to get the first one. So 9.5, now we can add 4 the rest of the way. And we end a little bit after the last one, so we're good. And all the other ones seem to fit in the cracks, so we're good there too. All right, now let's label everything. So I'm going to turn it. Fill everything in. Okay, so there's our boundaries. And that is talking about tar in milligrams. And so now what about our vertical scale? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. But our frequencies go up to 15. So it looks like we're going to have to go by 2s. All right, so let's go by 2s. I mean, the big thing is trial and error. Sometimes that's what you're going to have to do with these to, you know, if you guess too big, I mean, obviously if you went by 5s, that'd be fine. That'd be more than enough, but that's the problem. Your bars aren't going to use up the entire table if you use too big of a scale. So you want to try to find that happy medium when you're scaling these vertical scales for your frequencies. So, all right, so our first one goes up to 1. So we're going to go halfway up. Next one's 0. Next one's 15. So we're going to go halfway between 14 and 16. And then we're going to go up to 7. And then up to 2. All right. Again, not anything too drastic. It's a little time consuming, obviously, but you just got to put the time in and you will get it. All right. Now the last page is more of an introduction into other types of distributions. So we've already talked about the normal distribution. So this one's going to get into a few other ones that are important as well. Okay, so as with frequency distributions, we can examine histograms to determine anomalies in their distributions. For instance, we can more easily determine visually if a histogram represents a normal distribution or a uniform one. So uniform is going to be new. Likewise, we can also recognize that the distribution of data is skewed to the right or to the left. All right, so we had a few things we're looking at. So the first one is uniform. Uniform has the different possible values of the data set occur with approximately the same frequency. So the heights of the bars of the histogram are approximately uniform. So out of these four, which one looks uniform? Yeah, you guessed it. This one's going to be uniform. Because the bars are about the same height, and that's what we want. All right. Now, as far as skewed to the left and skewed to the right, this is a kind of a weird one, but if you read it, it explains it. It says, we'll have a histogram which will have a longer right tail. And a skewed to the left will have a histogram which will have a longer left tail. So which one is which for these? This one here, you can kind of probably guess that this one's just a flat out normal one. But I mean, it's not perfect. Obviously, there's a little bit of a missing values there, but overall, it looks pretty bell-shaped. So, but these ones are definitely skewed. So which one's which? This one is skewed to, oops, the right, and this one is skewed to the left. Again, it's based off of the tails. Now, in other textbooks, they look at it based off of where the hump is. If the hump is on the right and the hump is on the left, then it's skewed to the left or the right. But this one uses the tail to determine skewedness. So you got to be careful. Some books will do it differently. So because it's got a longer right tail, it's skewed to the right. It's got a longer left tail, it's skewed to the left. So that's how they do it in this textbook. So, all right, well, that wraps up this section. Next, we're going to be looking at other ways to do a graphical representation. And then there's going to be some PowerPoint in there that looks at when can graphs be deceiving. So that's important as well. So we'll see all that in the next maybe 1 or 2 videos. Stay tuned.